Fractions, fractions, and more fractions. Yes, it is. Well, today it's coming to an end. We are going to look at the last different thing that I can do with fractions after then finally we solve again equations. So, complex rational fractions. What does that mean? Complex rational fractions are basically just fractions divided by fractions. And the goal right here is to turn this into a simple fraction. Well, whatever simple means. So, for instance, if I give you an example here with numbers, something like this, 2/3 divided by, let's just say, 3/8. I have one fraction divided by another fraction. And if you remember, we are dividing one fraction by another fraction by multiplying with the reciprocal of the bottom. So 3/8, that will turn into 8/3. And now we are out of luck. There is nothing that can be simplified. So I would end up with 16/9. This right here is a simple fraction. This right here was a complex fraction. Of course, we are going to look at the x's and all of that good stuff. So let me just give you one more time one example with numbers. There are two different ways, really, two different methods how I can attack a problem like this. Up here, this is what in the book I believe they call method 1. Let's call this method A. And this one really is just looking at the problems as if they are two separate problems, the top and the bottom. And we are just going to go and look at the top. 2/3 plus 5 is 2/3 plus 5/1. Least common denominator would be 3. And that turns into 2/3 plus 15/3, which is 2 plus 15/3, which is 17/3. Now, the bottom down here is 7/1 minus 1/3, not the same denominators. We need to have a common denominator, and that will be 3 times 7/3, which is 21/3, minus 1/3 is 21 minus 1, which is 20/3. And now I'm doing the same thing as before. I multiply with the reciprocal of the bottom. In this case, there is something that we can do. There's a factor of 3 that can be cancelled out. Nothing else cancels, and my final answer is 17/20. So this looks like as if this is a lot of work, and it is. So my preferred method is method B. This is the one that I will be using from now on. So here's the trick. If I have a complex fraction, then I'm looking at the least common denominator between all denominators that show up. In this particular case, there are really only these two denominators on the inside problems. 3. 5 has a denominator of 1, so does 7. So that means that the least common denominator overall is 3. So what we are going to do with this is I use the least common denominator as a tool by taking this problem. Let me just rewrite the problem. And I multiply the top and the bottom by 3. In other words, I multiply this whole fraction, the complex fraction, by 3/3. Because what happens now is that this 3 is being distributed in the top and it's being distributed in the bottom. So there are a lot of shortcuts that students like to do. Once they have got a hang on it, let me just write down what is really happening. So the first fraction, 2/3, is being multiplied by 3. 5 is being multiplied by 3. In the denominator, 7 is being multiplied by 3. minus 1/3 is being multiplied by 3. And what is happening here is the nice thing that this 3 and this 3 is canceling out, so is this 3 and this 3. So in other words, in just one step, I have cleaned everything out. What is left is 2 plus 5 times 3, which is 15, divided by 7 times 3 is 21, minus 1, which is going to be 17 over 20, which hopefully is the same answer that we had before, which it is. So this method right here allows us for a lot of shortcuts. I have not used any shortcuts. I wrote down all of the steps. For you have to decide how many steps you write down. If you are uncertain, write down all of the steps. So let's do one now that involve these letters, our variables. I want to simplify x over 5 minus 5 over x all over 1 over 5 plus 1 over x. And I will use this method where I am finding the least common denominator and I multiply the top and the bottom by the least common denominator divided by itself. Because this again is nothing else but 1. So you multiply something by 1, that doesn't change anything. So what is the least common denominator here? Let me write down the problem one more time. Plus 1 over x. So what are the denominators? They are right here. Oops, that was not the right tool. They are right here. There's a 5 and an x. And there's also a 5 and an x down there. That makes the least common denominator being I take the 5, I take the x. There is already one 5 in there. There's already one x. This right here is the least common denominator. So this is what I now will multiply the top and the bottom with. 5x over 5x. And as a consequence, let me write down this step. I'm getting 5x times x over 5 minus 5x times 5 over x. So what I did, I multiplied this expression and I multiplied this with 5x. And the same thing on the bottom. 5x times 1 over 5 plus 5x times 1 over x. Maybe let me color code this here real quick so that you see what had been introduced. And this is what sometimes students like the only thing to actually write down. 5x, 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 5x. A factor goes to everything, because now what is happening is the really, really nice thing that in my first one, the 5 cancels out. In my second fraction, the x's cancel out. Here the 5 cancels out, and here the x's cancel out. And if I now just write down what is left, then I'm going to get x times x is x squared minus 5 times 5 is 25 divided by, well, the 5 cancels out, x times 1 is x, plus x cancels out, 5. So in one cleanup move, I have turned this complex rational fraction into a simple fraction. But beware, this should be ringing all bells when you see this expression right here. The numerator is the difference of two squares. And in the denominator, I had x plus 5. And that means that this x plus 5 cancels out, and the overall answer is just x minus 5. How crazy is that? From this long problem right here to x minus 5. All right, let's do one more. 3 minus 1 over y divided by 3 plus 1 over y. So all I have to find is the least common denominator, and there is only one showing up. This is going to be y. So what I will do, I will take the top and the bottom and I will multiply everything with y. This will be distributed in the first and the second one, so I'm going to get 3y minus 1 over y times y. You see already that y will go away. 3y plus 1 over y times y. This y is also going to cancel out. This is canceling out. And I'm looking what I'm left with. 3y minus 1 divided by 3y plus 1. Now this was much shorter and simpler than the last one. This is already your answer. There is nothing, please do not look at these 3's and think that you can cancel these ones out. These are not factors. Don't ever do that, okay? This is the final answer. There's nothing else that you can do with this. All right. Last one. Oh, I think there are 2 more. So let's have a look at this one. What are the denominators? There is an x in my first one. There is a y. That means the y also has to come. In the denominator, there is an x and a y. I have both of those. That makes x times y the least common denominator. And if I now multiply the top and the bottom with xy, then there is something really pretty going to happen. If I multiply it with this first fraction, what is happening to the x in the denominator? It will go away and I'm left with y. This x down here is going to cancel out with this x. Now, what is happening in my second fraction? This y down here is going to cancel out with this y. So I'm just going to be left with an x. In the bottom, what is happening right here? If I multiply this fraction, maybe I should put the arrow on the top so that it looks like right there. X times 1 over x, this x goes away, and the y goes away. And I'm just left with 1. So here's our answer. Y minus x. All right, this was really a very short one, even though it looked a little bit complicated to begin with. Let's do the last problem for today. 1 over x plus 6 minus 1 over x divided by 6. So again, least common denominator. I'm looking at my first denominator. There is an x plus 6. I look at my second fraction. There is a factor of x that has to come. The bottom part right here, divided by 6, is nothing else but by 6 over 1. So the least common denominator will be x times x plus 6. And just like the other times, I am multiplying the top and the bottom with x times x plus 6. So distributive property, and I will get 1 times x plus 6 divided by x plus 6 minus 1 times x plus 6 divided by x all over 6 times x plus 6 divided by 1. I don't need to write this. And I see this goes away and this goes away, and I will be left with what is left in my first fraction? just the x, minus, don't forget the parentheses, x plus 6. Don't forget the parentheses here. All divided by 6x times x plus 6. Now, I'm looking at the top right there, and this can be simplified further. If I open up the parentheses in my numerator, then I get negative 6 minus 6 divided by 6x times x plus 6. X minus x goes away, and I'm left with a negative 6 divided by 6x times x plus 6. Now, what I have in the top right there, this negative 6, can be thought of as negative 1 times 6. So there is a factor of 6 that can go away, and I'm left with a negative 1 divided by x plus 6. This is good enough to write it down as an answer. If I wanted to, I could pull this negative sign in front of the fraction, but on the homework, you do not need to. So this is right, and this is even righter if you wanted to.